At time t equals 0, a small ball is projected vertically upwards from a point A, which is 4.5 meters above the ground. Okay, let's draw it to make it simple. We have ball at time equals 0, projected vertically upward. Projected means we have initial velocity. And from a point A, which is 24.5 meters above the ground. Okay, now we have ground, and distance between this point A, and the ground is 24.5 meters. This is our height, let's say. Okay. The ball first comes to the instantaneous rest at point B. At the moment that we reach to rest, for example here, we are in point B, and here velocity equals 0 because it is the highest point, where AB equals 19.6. Okay, the displacement of these 2 points also given. AB equals 19.6 meters. And first hits the ground at time equals t seconds. Okay, it means that from t equals 0 to the top point and then turning back to the ground, so time will be t seconds. Total journey, total travel. The ball is modeled as a particle moving freely under gravity. It means that our acceleration equals g. Find the value of t. Okay, according to our information, we can find the time from point A to point B, because we know the final velocity, we can find the time from A to B using the formula S equals Vt minus 1 over 2 A t power 2. So we have displacement 19.6 equals final velocity equals 0 because maximum point we reach to rest, and minus 1 over 2, A is minus 9.8 because velocity is decreasing, our acceleration is negative. So acceleration equals minus 9.8 meters per second square. Multiply t power 2, we are going to find t. Okay, if you solve this equation, you will find t equals 2 seconds. Okay, since it takes 2 seconds from A to B, it will take again 2 seconds to go from B toward A. Okay, but we don't need it. We actually need the time of this point. In this point, when we hit the ground, our displacement is minus 24.5 meters because our origin is here, and we assume that this direction is positive. So displacement of AB equals 19.6. And here, since this is our origin, A is our origin, so the points below this point, the displacement will be minus. So we are going to use the formula of A equals V minus U divided by T, since we have the acceleration minus 9.8. we can find the initial velocity because final velocity equals 0 and we have time. So first of all, we can find the initial velocity, and after that we can find the time between the initial point and final point. Okay, this is one solution. Or you can write the equation between the point B and final point because you know the total displacement, and use another equation to find the time. So I prefer first to find the initial velocity u. So time equals 2 when it reached from A to B. So I can write the acceleration formula, which is v minus u divided by t. Acceleration equals minus 9.8 equals v equals 0 at point B minus u, I'm going to find it, divided by time, which is 2. We found it. Okay, now you can find u equals 2 times 9.8. It will be 19.6 meters per second. Now we have the initial velocity u equals 19.6 meters per second. Okay, now we have initial velocity, we have displacement from A to final point when we hit the ball hits the ground, and now we can find the time using the equation S equals ut plus 1 over 2 a t power 2. Again, be careful, since our origin is A, displacement will be minus 24.5. So I write minus 24.5 equals u, our initial velocity 19.6, multiplied time plus 1 over 2 a. Again, we projected it upward with initial velocity upward, so our acceleration is negative. Again, be careful because we go up then down, so our initial velocity and our initial acceleration should be written according to the initial point. Initial point velocity is 19.6, and since it goes upward, our acceleration is negative. That's why we write negative 9.8. Multiply again t power 2. Okay, so you should solve this equation using calculator, and you will find t equals almost 5 seconds. Okay, this is the first part of the question. Second part, sketch a time speed graph for the motion of the ball from t equals 0 to t seconds. No further calculation are needed in order to draw the sketch. It means that you don't need to find the final velocity when it hits the ground. You need to just sketch the speed time graph. Okay, be careful. Since it says that speed time graph, this is not velocity time graph. Be careful, speed time graph. So be careful about the signs. It will be always positive. Okay, let me bring access to make it easy to draw. Now, we have initial velocity of 19.6. Yes. For example, here is 5, 10, 15, 20. Okay, 19.6. Let's say it is here. 19.6, you should write the velocity or speed time graph. Let's write 9. Okay. Now, after 2 seconds, we reach to maximum height. So it means that from this point, after 2 seconds, we reach to, let me withdraw it. From this point to this point, we reach to the maximum height. And after that, after 5 seconds, let me make it more accurate. Okay, so after 5 seconds, 3, 4, 5. Okay, here. After 5 seconds, we hit the ground. With the same slope, our velocity will be increased. And we reach to the 5 second. I don't care about the velocity. Almost at 4 seconds. Here I should be exactly in 19.6, let's say. Okay, it's almost correct. So we don't care about the speed of the final velocity speed actually. It's enough because it says that no further calculations are needed to draw this sketch. Be careful, if it is velocity time graph, we should continue this graph from this point. Let me change the color. From this point to this point, because we reach to the maximum point and after that the sign of velocity will be changed. But in this question it says speed time graph. So our velocity will be 0 and then our speed will be 0 and then it will increase until it hits the ground.